Why does reality choose one outcome instead of infinitely many? Why does quantum uncertainty become classical reality? Why does measurement appear special? What if wave function collapse is not a mystery, but simply the process through which reality stabilizes itself? We have reconstructed reality from distinguishability, transformation, selection, geometry, and stability. But quantum mechanics still contains one of the deepest mysteries in physics. Why does information appear to disappear? Why do systems become irreversible? Why does quantum uncertainty become classical reality? Classical physics describes entropy statistically. Quantum mechanics introduces measurement almost as a special rule. But why these processes occur remains deeply unclear. This framework proposes that entropy, decoherence, and measurement all emerge from the same underlying informational process. Information depends on the number of distinguishable accessible states. I of S equals the natural log of omega A of S. The more distinguishable structures that exist, the larger the informational possibility space becomes. Omega A represents these accessible, distinguishable states. Irreversibility occurs when multiple earlier states converge toward the same later state. The size of the preimage is greater than 1. If previously distinguishable states can no longer be separated, informational loss occurs. Entropy is not merely disorder. Entropy is the irreversible loss of distinguishable structure. Under irreversible dynamics, distinguishable informational structure decreases over time. The temporal change of I is less than or equal to 0. Quantum systems exist as superpositions of possible distinguishable structures, represented by the state psi. Standard quantum mechanics describes collapse, but does not fundamentally explain why one branch becomes reality. This framework proposes that collapse is not magical. Collapse is informational selection. Update continuously evolves superposed informational structures. Selection follows transformation. Environmental interaction destroys distinguishability. The system is no longer isolated. It becomes part of a larger, irreversible flow. Decoherence occurs when unstable distinctions are irreversibly filtered away. Reality begins to stabilize. The classical world emerges as the stable limit of repeated informational selection. Stability is persistence. Observers are highly stable informational structures participating in selection. We are part of the process, not outside of it. Collapse emerges from irreversibility and selection, not from mystical consciousness. It is a physical, informational necessity. Macroscopic systems experience enormous irreversibility. The scale of interaction is too great for uncertainty to persist. Large irreversibility density, sigma I, rapidly destroys unstable branches. The informational cost of maintaining the superposition becomes infinite. When geometry remains stable and irreversibility dominates, classical reality emerges naturally, the regime of Xi being much less than 1. Reality may simply be the branch capable of persisting under irreversible selection, the branch that survived. Entropy, decoherence, measurement, and classical reality may all emerge from the same informational process, a unified dynamic of stability. Classical reality may not be fundamental. It may emerge from stabilized informational selection inside an irreversible universe. In the next lesson, we will ask the deepest question of all. How could distinguishability emerge from nothingness itself?